guys, welcome back to another video. So in this video we'll be covering functions, objects and strings. We'll be diving deep into these topics and let's see what we can do. Okay, so everything is working fine. So let's dive into functions first. So we have already covered the basic stuff about functions, right? So we have covered function declaration, anonymous function, arrow function, iffy function, right? We also discussed about the difference between parameters and arguments between functions. So let us talk about default parameters, right? So let's say we are defining a function test and it is expecting two arguments, first name and last name. Last name is initialized with Kumar. So if you call this function without passing the last name, the default value will be replaced with Kumar. So if you call it with some value, then it will be replaced with that value. So, test Harsh Sangwan will print hi, I'm Harsh Sangwan, and test Arvind will print hi, I am Arvind Kumar, because last name is not passed, so it will take in the default value. So let me just run it. Okay, it is taking some time. I guess it's because of the heating issue with my MacBook. It's got pretty much heated up and the environment is also having right. So here you can see I am Hassangwan, and if you are not passing any argument, it is taking up the default value, right? So that's it about default parameters. Now we will talk about rest parameters. Suppose we want to build a function that takes in n number of arguments, basically the variable number of arguments. It can take up 1, 2, 3, 4 and so on. So how we are going to actually get those arguments? That is present inside of something known as arguments. That is a type of array that is pre-built. Every function has access to this property called as arguments. That is our array, and we are looping over it and calculating the sum, then returning it. Done in ES6, developed in 2015. This version was released. There we had something called as rest parameters. So triple dots, then followed by the variable name. It is gonna take everything inside of an array. So right, that is the case. Now let's test using the variable argument. So let's suppose we are defining like this. So what is going to do, it is taking up the first two values as a and b, and the rest of the remaining values, whatever the number of values are there, it will be present inside the C array, right? If we write another variable, that is not valid, because rest parameter has to be the last. It is accepting a list, so it can expect any number of arguments. So why there is a need, is there any need to declare another variable after it? No, because it is taking up entire set of a list of arguments inside it. So there is this will be called as a syntax error if you try to do it. So that is about the rest parameter, right? Let me check the stream whether it is showing up correctly or not. Just give me a moment. Okay. That is our array and functions. Now there is something called as higher order functions. That is just a fancy name for a function that can accept a function as an argument, or that is returning a function from its return value. So suppose I'm defining a function show like this, and we are defining another function fn like this, which is having a callback as its argument, and we are calling this, and we are passing show inside it. So what does it do? It will simply call up this fn function. It will print out this line, and then it is going to execute cv function. Then it is going to execute the cv function, right? So it is going to print I am sure after it. So let me just run it. I am fn, and I am going to call callback function, and I am sure is appearing, right? Now what we are doing is we are returning a function out of it. So result will be a function, and we are calling it. So this is known as a higher order function, because it is returning a function. Either it has to accept a function as an argument, or it has to return for it to be called as a higher order function in JavaScript. So let me just run it. So it will print out 1, because count value is going to be increased, and it will return the count. So it is coming out to be 1. So that is it about function. We have covered each and every basic, from very scratch to the advanced topic. We have covered each and everything about functions, right? Functions code. This is done. Now let me talk about something called as objects. So objects, we have seen that we can define an object using the square bracket notation, and we can also define objects with couple of more things that we are going to see in this video. So I have defined an obj like this. So right, you can define object like this, or you can use object.create. Using object.create, you can also define an object. Now what is it going to do is, it is gonna let me just comment out the other code. So what I'm doing is I'm declaring obj, and then I'm using object.create to create another object. Now what is it going to print? It is going to print an empty object. Object.create is going to create an empty object. That is very important to note down. So it is running up. Just a moment, it will show me the output. Right, it is showing me empty object. So what if we try to access name property out of it? Will it be able to print it? Yes. How so? How so? It is going to print the name property even though it is having an empty object. How? So let me just decode this thing using my developer tools. So I will go to about blank. Let obj2 object.create obj2. It is having undefined. Now it has access to something called as prototype. That is nothing but object2 __ proto. It is storing the object, this object, inside this proto. So it is that is how it is able to. If it is not finding inside this empty object, it will go underneath. The linking is happening via proto. So in JavaScript, we have this hierarchy. Object is a super type that is being inherited by array, object, and function. Object is just a simple plain object. If we are declaring it using object.create or using curly braces, that is then its proto will point to object. Arrays proto will point to object. Function proto will point to object. And at the end, if you are declaring a array, then its proto is pointing to array.prototype. Test proto is test proto is pointing to function prototype. So that is the hierarchy. Now object 2 is linked with object via proto. Proto is linked with object's prototype, and its proto is will point to null. At the end, something has to be stopped. So that is object's proto is will be null. So if I write object dot prototype and dot underscore underscore proto, that will come out to be null. So this is the hierarchy we have. So if you create a function, then its proto will point to function type, and function will be linked with object. If you create an array, it will be linked to array type, and array will ultimately be linked with object. So that is what is happening. So we have something called as object.define property. That is how you can create another object. You have to define an object, then you have to define it like this: the object, then the key name and value in the object. Enumerable stands for whether we can iterate over the property or not. You can access the property if it is false, but you cannot iterate over it using the for in loop or any other kind of loop that you use. You can access the property if enumerable property is false, you can access it. Object 3.age is coming out to be 22, but you cannot use a loop the loop will not be able to access this property. That is very important when enumerable is set to false. Right. So it will be only printing 22. Okay, I'm printing this age as well. Okay, yeah. Why it is slowing down, man? What's the issue? I think OBS is taking too much of space. Right, so it will only print out hash because it will not be able to access if the property is set to enumerable set to false. Right, so this is it. This is how you create object using object literal, using object.create, using object.define property. Now let's talk about copying an object. Now what if we have an object and we define another object like this, and we try to change the name? Will it be reflected back in the object? Yes, because they both are pointing to same memory location inside the heap. Right, if I'm changing name to Vinay and it is also getting reflected in object. So what's the memory diagram for this? So object is pointing to 4K. 4K is nothing but an heap memory location. Inside it we are having name, age and address. Address is another object pointing to state. State is another object that is having this property. And object 2 will be pointing to 4K, because we are assigning it the value as obj, and obj is pointing to 4K. So object 2 will also point to 4K. So this diagram will look something like like this. Now we have something called as shallow copy. We can use the spread parameters. Now this is known as spread. In the case of function, when we are accepting the argument, in that case it is known as rest parameter. Otherwise, when we are copying using 3 dots, that is known as spread parameters. That is known as spread. So this is going to create a shallow copy. It is going to create copy in another memory location this time. In another memory location. Now it will point to another memory location, and the same property will get copied over here, and address will still point to 6K. Address will still point to 6K. So if you try to change the name, it will not get reflected in the obj. But if you try to change the address.state.code, it will be reflected inside obj, because it is having the same memory reference as the address is having in the obj object. So if I try to print it, it will give me, okay, let me comment out this. If I run it again, then see, Vivek is not getting reflected in obj, but the state code is getting reflected 2345. So this is known as shallow copy, where you are not going deep nested inside the object, but you are only going one level deep and copying all the values into another memory location. So that is known as shallow copy. You can do so with object.assign as well. This is another function provided by the object, where we declare the target and the source from where it is going to copy the properties. This is also going to do the same thing in the case of spread parameters. So this is going to reflect back in 2345 in obj. You can also do so using object.create as well. It will still reflect back 2345 in the previous object. So this is how you can create shallow copy using spread, using object.create, using object.assign. That is how you are going to create a shallow copy out of it. What if you had to create a deep copy, which means every property is going to be unique and will be defined at a separate memory address. How can you do so? You can use something pre-built using json.parse, that is going to parse everything that is stringified by json.stringify. json.stringify does nothing but it creates a new memory location object at new memory location with keys with stringified version of them. Keys will be in string format. So that is going to parse, and we are converting back them into object. So that is going to point to a new memory location. So if you try to change the object, then it will not be reflected back, because everything is defined at a new memory location. So it is not going to be reflected back in the object. Right? You can see 1, 2, 3, 4 is coming up, not 2, 3, 4, 5. Now this time complexity is very bad. O of n square. It is doing a very heavy operation. So we have to define something of our own, deep copy. Now what I'm doing is I'm creating a result object. Then inside I'm passing over the given object. And if the type of key is object, then this is going to be created as a new memory location. So we have to again call the deep copy function to give us the new object. So it is going to create a new object out of it, and then we are storing it inside the key that is created as another separate memory location. So that is why we are doing this recursive call. And if the object is not an object, if the key is not an object, then it is simply assigned to this value, this object in its key, and we are simply going to return it. And if you check the output, it will be same as above, but it is happening in O of n time. Time complexity for this is O of n. Right, so this is about deep copy. Objects done. Now let me talk about strings. So strings are immutable, which means if you try to change anything inside of it, it is going to create a separate string and it will copy the previous values, and then it is going to append the new values in it. So what does the memory diagram looks like? It will look something like this. So first string was pointing to Harsh. Now we are changing it to appending 1, 2, 3 after it. So it is going to create a new string. Then the string str will point to this newly created string. And there are some functions that we can also use to make our life easy. If we want to create if you want to convert each and every alphabet to its uppercase, then we can use something called to uppercase. But it is not going to change the original string. It is going to create a new copy where it will map each and every character to its uppercase value.